Good morning, everyone. I am Professor Vivek Pongade, Assistant Professor, Department of ISC, Science of Technology, Ajankunte, Bangalore. In today's class, we're going to see the three-scheme architecture and data independency. Three-scheme architecture and the data independency. Basically, why we need this three-scheme architecture? So this why we say the three-scheme architecture means because whenever the request is sent by the end user, it's going to be processed in the database in the form of three levels. One is the external level, second is the conceptual level, third is the internal level. That's why we say it as a three-schema architecture. It's going to be performing between the three schemas. One is external schema, conceptual schema, and the internal schema. So, what is the main goal of three scheme architecture is to separate the end user with the physical medium, with the storage database. Means, so whatever here, the end user will not come to know where the data has been stored, in which server the data has been stored. One example, one basic example for this one is consider the same Amazon application. When it comes to Amazon application, we the end user, we the customer, just log in into the Amazon application, and we're going to see the product information. But we don't know where the product related information is stored. In which storage area, in which storage medium the data that particular data has been stored. It is not that the data information will not be there with the external level, that with nothing with the end user. It as we the end user, we also don't bother about the data. So, in order to provide that thing in the three-scheme architecture, it will the main aim of the three-scheme architecture is to provide the hide between the end user to the storage database. This is the main aim of using three-scheme architecture. To do this process, we're going to use the external level, conceptual level, and the internal level. We're going to see one by one. First one is the internal level. As I said, internal level, nothing but internal schema. Here, where the data has been stored in where storage area, right? It is the storage area where the data has been stored, which and that's why it is describes the physical storage structure of the database. It describes the physical storage structure of the database, where the data has been stored and in which path the data has been stored, from which path the conceptual schema is going to assess that one. All those information, related information of the storage will be there in the internal schema. That's why you said as internal is nothing but a physical storage medium. Physical storage, it contains the storage structure of the database. When it comes to conceptual schema, the conceptual schema describes the structure of the whole database. Describes the structure of the whole database, means that how the data is being stored. Okay, means what is the type of the data, then what is the size of the data, how the structure of the data, and what is the definition of the data. Each and every information of the data is going to be there in the conceptual schema. It is there in the conceptual schema, and the main role of the conceptual schema is that it's going to hide the data. It's going to hide some details, hide the data details while it is sharing with the external level. What it's going to hide? For example, if the end user send a request to the conceptual schema to retrieve data from the database, while retrieving the data, after retrieving the output from this internal level or from the physical storage, this conceptual schema will hide the details of this data. Okay, what it's going to hide? It's going to hide the data type, structure, then the definition of the term, what type of data it is going to share, from where from which path the data it has been retrieved. All those things, all those information, it will hide with the external level, hide with the user. So the main role of the conceptual schema is to hide the details of the physical storage data to the external level. So, and when it comes to the external level, so external level is like a application front end page for the end user. From here, they're going to send the request. For example, the same in Amazon application, the front end application where the user is going to view all the data, right? So when we have a user or when we're going to log in into the Amazon application, there we're going to see the data, the products, right? So that is the front end view. From view, it's going to send the request for the conceptual schema. From some conceptual schema, it's going to process and send to the internal schema. That process, after sending that request, it will retrieve the data, and the data is going to be sent for the external level. Said the request has been transferred. The request has been transferring from external level to the internal schema, right? The transferring of request between the levels, the transferring of request between the levels, the external level, concept level, internal level. This we say it as mapping. This we say it as a mapping. Mapping means the process of transferring request, and the request is sent to the levels is said as the data independency. Which is the name we're going to say that data independency. If we modified somewhere in this schema, for example, if we modified in the concept schema, with the modification, the external schema and the internal schema should not affect. That is why we set as data independency. So in data independency, we have two types. Data independency means if we change the schema, it is not going to affect the concept schema. If we change in the internal schema, it is not going to affect the external schema. That is what the act of. That we say it as a data independency. So data independency is of two types. One is logical data independency. Second is the physical data independency. So what is logical data independency? If we change in the concept schema, if we modify the concept schema, it is not going to affect the external schema. It is called data independency. When it comes to physical data independency, the name will even say that physical. Physical means it could indicate the storage level, that means internal schema. If we change in the internal schema, it is not going to affect the conceptual schema. That is what the physical data independency. So the three schema architecture is basically required to hide the details, required to hide the details in between the levels. Who going to do that one? Conceptual schema is going to hide the details of the internal schema to the external level. And when it comes to the process of transferring the request between the levels, we say it as a mapping. When it comes to data independency, if we change at the one schema, the other schema is not going to affect the data independency. There are two types of data independency. One is physical data independency, other is a logical data independency. So physical data independency means if we change in the internal schema, it is not going to affect the conceptual schema. What is logical data independency? If we change in the conceptual schema, it is not going to affect in the external schema. This is what a three schema architecture is. So thanks for watching the video.